All right, and then once we've got some kind of goal written on the top, your name is on it, all that good stuff. Go ahead and turn to the first page of notes. We're going to start with 2.5 today. And we're kind of, with this, in a way, baby stepping our way into proofs for geometry. So like last week and even, early this week, we did algebraic proofs, right? Which involved kind of solving an algebraic equation on the statement side, and then listing reasons like multiplication property and division property and distributive property on the reason side. Now we're going to kind of gear up to do the same thing, but with geometry stuff. So with segments and angles and things like that. So today, onto the notes here, we're going to talk about some different definitions and postulates from geometry that we're going to be using these kind of in the reason column on our proofs. So we're going to see what these definitions are, see how we can use them, how to recognize when we might need to use them, and things like that. So today, starting off with some notes. They're a lot more fill-in-the-blank style than usual because I didn't want us to spend the entire period writing things down. We want to actually go through and apply these concepts. So here we go. First one, definition of congruent. The measures of two congruent items are equal. Measures of two congruent items are equal. So an example of this and how we would use this in a geometric proof. If your first statement said something like AB is congruent to segment CD, and your second one said AB is equal to the length of CD. Anytime we go from having congruent between two items to having equal between those same two things, that would be the definition of congruent as our reason. So then we would put over here under reasons, definition of, of with an F, congruent. If you want to abbreviate definition with DEF, you're welcome to. Jacob, phone away, please. All right. Next one. We're going to see a lot of definition of something. So definition of midpoint is the next one. A midpoint divides a segment into two congruent segments. All right. So if we're given a picture like this one, A, B, and C, and maybe we are told that B is the midpoint of AC. If we're given that information, then we can conclude that AB is congruent to BC. And if we wanted to add labels and things to our picture, we could put a couple little tick marks here showing that these are the same length because B is the midpoint. And so if I was told B is the midpoint of AC, and then I saw something like this under the statement side of my proof, my reason would be definition of midpoint. In fact, anytime you see midpoint mentioned in a proof, there's a good chance that definition of midpoint is going to be a reason somewhere along the line. So that's a common one used there. Next one, segment addition postulate. And we've used this one before, and we've talked about it before. We just don't always call it, postulate and stuff like that when we talked about segment addition. This is that one where you've got like B is between A and C. So if you add the two small parts of the segment, it equals the whole thing. So it's the idea that two smaller segments add to equal the whole segment. It's the idea that if you have a picture like this, with B is between A and C, then AB plus BC is equal to the whole thing, AC. So anytime we see a picture like this, and this is somewhere on the statement side of our proof, the reason is the segment addition postulate. That's what allows me to add those two segments and set it equal to the entire thing. All right. So just like segment addition, we also have angle addition. It's the same idea, but it applies to angles instead. Two smaller adjacent angles add to equal the whole angle. It's this idea that if we've got something like this, we call this P, Q, R, S. It's the idea that if we have a picture like this with adjacent angles going on, that we can say the measure of angle PQR, this one right here, one of the small ones, plus the measure of angle RQS, the other small one, is equal to the measure of the whole thing, PQS. So PQS being the whole thing. So anytime we see a picture like this and a statement like this in our proof, the reason is going to be angle addition postulate. Okay. The picture on the next one is going to look similar. It's a definition of angle bisector. So an angle bisector divides an angle into two congruent angles, is the idea. It's kind of like the definition of midpoint for segments. This is the way it is for angles. All right, so definition of angle bisector. An angle bisector divides an angle into two congruent angles. So if we've got a picture like this, and let's see, A, R, H, S. And we are told something like ray RH bisects angle ARS. What that tells me is that RH is cutting this angle in half into two equal pieces. So then I know that this piece is equal to this one in size. So under the statement side of the proof, I could see something like angle ARH is congruent, so that's this one right here, to angle HRS, this one right here. And if I were to see that after knowing that this is a bisector, my reason would be definition of angle bisector. So basically, anytime you see bisect or bisector in the given portion of your proof, there's a very good chance that definition of angle bisector is going to come up. Okay. Then more angle relationship ones. So the next several are basically formalizing all of our angle relationship knowledge. We've got vertical angles are congruent. This is sometimes also called the vertical angles theorem. So off to the side, maybe we'll write vertical angles theorem. That's another way that you might see that written. Or occasionally you'll see like definition of vertical angles or something like that. So there's different ways that you can see and recognize that one. Basically, if it mentions vertical angles, this is what we're talking about. It's that two intersecting lines form congruent opposite angles, which are called vertical angles. So whenever we hear vertical angles or think about vertical angles, we're thinking about this picture here where we've got crossing lines going on. Maybe I'll name them with numbers just to make it easier right for us. So if we see a picture like this, what's one pair of vertical angles in the picture? Yeah.
2 and 1.
2 and 1. Yeah, so we might see angle 1 is congruent to angle 2, and our reason for that would be vertical angles are congruent, or vertical angles theorem. What's the other pair? 3 and 4. So we could also see angle 3 congruent to angle 4 for the same reason. All right. Getting close to the end of our new reasons here. 3 more on this page. Don't worry, there's only 1 on the next page. Definition of complementary angles. What do complementary angles add up to? Yeah, 90. That's the one where they add to 90 degrees. I know it's always, is it 90 or 180? Because there's a lot of things in geometry that either add to 90 or add to 180. And you'll see 180 become a huge theme as we go towards triangles and things like that later on. But anyways, complementary adds to 90. So there's a couple ways you can see complementary. You could see it if there's like a right angle, and it's split into 2 angles, maybe angle 1 and angle 2. You could say that the measure of angle 1 plus the measure of angle 2 equals 90. They don't have to be adjacent like this, though. They could be non-adjacent, and but you're like told that they're complementary. That would also be a situation where you could have the angles add to 90. But if you see something like this in a proof, measure of angle 1 plus measure of angle 2 equals 90, your reason for it is going to be definition of complementary angles. And then the same idea for supplementary, but this time what do they add to? 180. So for supplementary, we could have something like this, where we're told angle A and angle B are complementary or supplementary. And then be given the equation measure of angle A plus measure of angle B equals 180. Yeah. Yes, the notes will be in Google Classroom later. Yeah, I know the supplementary is probably really tiny here. But yeah, it's supposed to say angle A and angle B are supplementary. It's a little hard to fit in the box. All right. And then really the only difference from supplementary to linear pair is the picture. Because linear pair, they have to be adjacent angles now. And then they still add to 180. Also, occasionally, you'll see this as not definition of linear pair, but as linear pair postulate. So that's another way we might see that occasionally, linear pair postulate. Okay. And then the only difference in the picture here, we might have, I don't know, let's see, angle 3 and angle 4 here. And our picture has to be like this, where they're adjacent, versus supplementary, where they could be adjacent, but they could also be non-adjacent. All right, so then we'd also get the equation, similar to the one before, but this time measure of angle 3 plus measure of angle 4 equals 180. When we see that and the picture looks like this, definition of linear pair or linear pair postulate would be good reasons to pick. All right, leave that up there for a second. Once you have it, go ahead and turn the page. And we'll do one more definition and then talk through a couple of examples. What?
Is there homework in the packet?
Yes.
Looks like it's mostly notes.
There are a lot more notes that go with this unit just because we do a lot of examples together. But yes, there's also homework within the packet. All right, on the next page. We talked a bit about perpendicular yesterday, right? We talked about perpendicular bisectors specifically. So perpendicular or definition of a right angle are other things that you'll see here. It's any angle that measures 90 degrees. So if you see something like this, and you're told that maybe these two lines are perpendicular to each other, or in the picture you see something labeled as a right angle, maybe it's angle 1, you can say measure of angle 1 equals 90 degrees, because that's the definition of a right angle, or you could say definition of perpendicular. Depending on the language that's used in the proof, that's what you're going to want to use as well. So if they tell you something is a right angle, say right angle. If they tell you things are perpendicular, say perpendicular. Okay, so some examples that are going to look like the problems that you'll see on your homework today. The first one. Let's see, we've got a picture that goes with it. Angle A. And we have angle B. And we might see something like step 1. Angle A is congruent to angle B. And statement 2, measure of angle A is equal to measure of angle B. So we might see something like this and be asked, of the reasons that we just wrote down and talked about, which one goes with this setup here? We're going from two things being congruent to their measures being equal. So look back through your list of things once you've got this written down. And look for one that kind of matches what's going on here.
Definition of congruent.
Definition of congruent, exactly. That's the one that goes with this. So under step 2, you would say, for your reason, definition of congruent. Okay. Or for another one, if we've got a picture like this, and something like PQ plus QR equals PR, look through your list. What does this look like? Look through your list. Do we see anything that looks kind of like this? Yeah, what do you see? Segment addition. Yeah, this is the segment addition postulate right here. So anytime we see this under the statement side of a proof, our reason, segment addition postulate. This one will have the picture A, B, L, and E. And we are going to be told that the ray BL bisects angle ABE.
Definition of angle bisector.
Yeah, definition of angle bisect is what we're going to use. And sometimes in a proof, you'll be asked to fill in what's congruent to each other because of this. And you'll be told that it's definition of angle bisector. So usually what I like to do here when I'm given a situation like this is take, okay, we've got BL bisects angle ABE. What can I label in my picture that's congruent to each other because of this? If this is the bisector, yeah, ABL, and then what's the other one?
BLE.
Close.
LB.
LBE, there we go. Yeah, remember B's the vertex here. Yeah, so I would label these two. The minute I see something like this, label what's congruent in your picture. That's going to be a big part of what we work with this week, making sure that if you're told something, label it. But anyways, what would go in here would be then angle ABL and angle LBE, the two that we just labeled as being congruent to each other. That's an easy way for us to tell what's supposed to go in here once you label your picture. All right, and then one more before we start looking at homework problems. This time we've got a segment, and we are told S is the midpoint of AK. All right. And then when we see these words like midpoint or bisect, that's a huge red flag that we're going to be using, like definition of bisector or definition of midpoint. So S is the midpoint. What can I label in my picture as being congruent?
AS and SK.
AS and SK. And then that's exactly what goes down here. Segment AS is congruent to segment SK. And then we're good. All right. Once you have this, go ahead and turn the page. Wait a minute, though. I still see people writing. All right, the next page does have the homework on it. It's 9 problems, and we're going to kind of go through with the first 1 or 2 what's expected on these problems. Okay. So it says in the instructions, give the reason for each of the following statements. So acceptable reasons would be like the ones that we listed on our page before this, like all of our different postulates and definitions. Those are all reasons that we're picking through for these. And then also draw a picture representing the situation. Okay, so sometimes it's easier to draw the picture first. Like in the first one, we're really good at drawing this kind of a picture. We've done this a whole lot. B is between A and C. Draw what that looks like on your paper. For segments, B is between A and C. Draw what that looks like. We've drawn this picture a lot. So if you drew something like this with ABC on it, that's the picture we're looking for here. So AB plus BC equals AC. Which of our postulates or definitions does that look like? Look on your list of definitions and postulates. And then tell someone near you. What would you pick? Tell someone nearby. What would you pick? All right, I heard a lot of murmured segment addition postulate. Are people showing each other a paper that works? Segment addition. O-N postulate. All right, and then this one is supposed to have segment markers above it. All right, anyway. This one, if AB is congruent to DC, AB, the length of AB equals the length of DC. What could that look like as a picture? You have segment AB and you have segment DC, and they're the same length. Try drawing a picture of what that might look like. Two segments to be equal in length. Personally, I would start by drawing two segments. All right, if you drew something involving segments, like maybe we've got segment AB, and then we have segment DC. How could I show on my picture that they're congruent to each other? Yeah, the little tick marks, like that. So that's all we really need for a picture. And we're going from congruent segments to saying that their lengths are equal. So look through your list of reasons and see if you can find one that goes with that. Once you think you found one, tell someone nearby what you decided on.
You have to draw the pictures.
Yes, you gotta draw a picture to go with it. I know.
Maybe
At least there's only 9, right? This could be worse. All right, what do we pick for number 2? Anyone want to volunteer theirs? Yeah.
the definition of congruent.
Perfect. Definition of congruent. Anyone else decide definition of congruent? See some thumbs up. Yeah. Definition of congruent. Anytime you go from congruent to those same two things being equal or the other way around, definition of congruent. Okay. So you have the rest of these 3 through 9 as your homework assignment for today. Go ahead and get started on that. If you have questions, I'll come around.
I didn't get pictures.